this computer. So I'm going to do a bit more review today. And then I've got a bunch of questions from another professor, a compatriot of mine, collaborator, colleague, that's the word. Got some questions from a colleague of mine. And I said I thought they would make good review questions. And so I've got that as a 5-point quiz today that I'll give us like 15 minutes to do. Just some good theory questions that I think will help you practice for the actual exam, and they're quiz points. So not really super important points, but figure that's a way to get some exercise in today. Otherwise, let's see. Your final exam, right. So your final, I'm going to send this out in an email because I forgot. It's in Circ 116. That is where we're going to take our final exam. Our final exam, Circ 116. So one of the big giant rooms in Circ. Okay. And I will send it out as an email. The final exam is going to be much like your previous exam, like exam 2, where there's a bunch of stuff that can get auto graded and then a bunch of code that I'm going to go in and grade. Make sense? I say a bunch, but not really. There's 3 coding questions. 3:30, I believe, since it's a common final. I will resend out all the information. Right, I will resend out all the information so that people don't go awry. Again, as far as demoing, I will cut today's class a bit short, like stop at 3:10 or something, and then I'll take some demos with whoever needs to. And then if you still need a demo after today, I'll be happy to do so in the upcoming weekend. So no worries there. Now, the first thing I want to talk about is practice. Okay. Now let's see. So practice in general. So this is probably like, where should I go for if I need more questions? Okay. So if you're on campus, one of the easiest things you can do to get more questions is head to the library, like the Temple library, right? And then go and pick up and look in the computer science section, pick up an old textbook that looks like it's got the right stuff in it. And then that stuff will have a bunch of questions in a much older language, but there's still going to be valuable questions. You know, still going to be stuff on Dijkstra's and the like. Like this one's in a much older programming language, but that's fine. Still got a lot of the stuff like Dijkstra's algorithm and how that works. But that's one way. That's a way for, if you want some extra questions and you want them in paper format and you want something that you're pretty much not have seen before, right? If on the other hand you want some like really heavy duty practice, I recommend this book, which is Cracking the Coding Interview. Sorry, this is an older edition. This is extremely well known in the interviewing world. Still very good book. It's $25. And while that's not necessarily great right now for the exam, it is great for programming interviews that rely a lot on data structures. I think you'd be very surprised. I think you'd be very surprised as to what you can answer. Yeah, everybody does recommend it. It's a good book. Because it's got a good collection of programs. They're programming problems. They're organized and they have hints arranged in such a way that you cannot accidentally spoil yourself on other questions or answers. It's good. Okay. But that's like, this is great for like, again, interviewing for a co-op or an internship, which by the way, now that you're done with this class, you totally should consider. So I would totally recommend you do that. Okay. Next, on the same vein is PRAMP, which I've mentioned before in class, which is short for practice makes perfect. Practice makes perfect. It's peer-to-peer interviews. Let's see, it is free. Last night, at least when I did it, not sure what the 20% off thing is. Course on data structures and algorithms. So, and whatever, if this is a good peer-to-peer service, you match up with somebody else, it's good. Next, for the more abstract mathematical problems, something I've used quite a bit, twice in this class, Project Euler. Project Euler has a bunch of math questions that a lot of which need data structures and algorithms kind of things to solve them. For instance, and some will challenge your knowledge, like number 13. How in the world do you do this? You've got to work out the first 10 digits of the sum of the following 150 digit numbers, but these digits are bigger than longs. So how do you deal with things that are bigger than what your primitives can store? The longest collat sequence is a good one. Lattice paths is one of my favorite ones because it introduces it can introduce you to linear programming. No, dynamic programming. So this, again, even early on problems, these are very good kind of puzzles for you to work on. It's all very good. And then finally, for those of you who like their puzzles to be more fun than abstract, I recommend Advent of Code, which is held every year during the lead up to Christmas. Apparently, yep, it was last done in 2021, and it's kind of the theme of only you can save Christmas for Santa and the elves using programming. It's, you know what, it's an excuse to be fun, and so it should be. It started out as just kind of a number of years ago as like a bunch of puzzles. There's 2 puzzles a day, so you typically do a puzzle, and then and you finish the first one, and then it builds off it for the second one. And of course, now that that's over, you can just jump around and do it. It's very good programming problems, and a good way to practice. In general, practicing, again, is one of the best ways you can get better at programming. And it should be something that you think is fun. So these are, again, just great exercises if you're worried about this kind of stuff too, about the exam, which of course you are. Of course you're worried, but study and it will be fine. All right, so let's go ahead and look at some of the other questions that I had from so I took my kid to play with his friends the day on Saturday, and then Sunday they tell me that their kid is now feeling sick, and so now Laser woke up going with a nasty cough. Just, he seems fine. If he coughs, it sounds nasty. And now, of course, I'm just starting to feel under the weather, which is great. But that's fine. That's what happens with kids. Okay. So I very much like this question over here, question 5. Suppose you have a hash table and inserted some elements. When you inspect it, you see that the result looks as the picture does below. Being a good student, you realize this is a problem. And part A is what the problem is here. But before we do part A, I just want to preface this by asking, what is the collision scheme, collision resolution scheme that is being used here? Right? We have linear probing, and what's the other? Sorry, we have open addressing with linear or quadratic probing, and this is chaining. Yes, that's correct. It is chaining or buckets or links. It's fine. We'll understand what you mean. Okay, so what is the problem here? And you can either dump it in chat, or you can just spit out your answer. Okay, so the problem here is that we've got a lot of unused spaces, a lot of clumps. Sorry, a lot of things that have basically been sent to a bunch of spaces. If we notice, like every single odd space and some of the even ones are unused. Like 1 is unused, 3 is unused, 5, 7, 8, 9, bunch of stuff is unused. Okay, so it's not evenly distributed at all. So what is an example of a hash function that could give rise to this behavior? So that's a great question, Professor Rosen. A great, so an example of a hash function that could give rise to this behavior, we got to look at the commonalities. And if we stare at this for a bit and read it out loud, 0 has index 0 and 30, 2 has index 21, 31, and 1, 4 has index 2, 6 has index 33 and 63, 10 has index 15, 12 has 26 and 6, 16 has 38 and 8. So we notice just from speaking that, and that sometimes helps a bit more, that basically everything that is together ends in the same digit, right? Over here, we have everything ends in zeros, ends in ones, ends in twos, ends in threes, ends in fives, ends in 6, ends in 8. So how does that correspond to where they end? Because they're certainly in order. So zeros are at 0, ones are at 2s, 2s at 4, 6s are at, sorry, 3s are at 6s, 10s are, 5s are at 10. So it looks like that it's the last, that the index they end up in is the last digit doubled, which, because I've done way too much of these kind of things, I know how to write that in math, which is that we do h of x is equal to, so given our number like this, the place I want to put it is, we're going to take x, mod it by 10. Okay, we're going to x, mod it by 10, and then multiply by 2. So we get the last digit. That's what modding by 10 does. And then we take that and we multiply it by 2. So the ones end up in 2, the 2s end up in 4, the 3s end up at 6, the 5s end up in index 10, the 6 ends up in index 12, 8 at 16. Make sense? Make sense to anybody, to everybody? So what would be a better hash function? Pretty much anything other than pretty much anything else, but not this. That would just make it even worse, right? So, but we want it to be distributed fairly evenly. So I guess like everything should have a relatively equal chance. So I mean, if I did h of x is equal to x mod 20, because there's 20 spaces, that would be good. Although the mathematician in me wants to say, hey, we should totally use x mod 19 because 19 is a prime number. And when we do this kind of modular division with prime numbers, that leads to less collisions. And that's something that gets more into depth and algorithms, and check your textbook if you want that. I think it goes into more detail there. All right, another one, problem number 7. Okay, suppose we first can insert an element x. Okay, we want to take x. Oh no, we want to take. We want to take x and we want to insert it into a binary search tree that does not already have x. Okay, there we go. Binary search tree does not already have x. And then what we do is that we immediately delete x from that tree. Make sense? So we're going to go ahead and put X in to this tree, and then we go ahead and delete it. Okay. So will that new tree be identical to the original one? If yes, give the reason in no more than 3 sentences. Now, I'm supposing that we are not asking about a ship of Theseus situation here, which is a great, interesting philosophical puzzle. And that basically it has not changed, and that we are not going to subscribe to the view that because we have added something and removed it, it has changed from it originally was, then that somehow fundamentally changes it. No, we're asking, is it, if we compared, if we saved a snapshot before and a snapshot of after and did a dot equals, would they be the same? Would they have the same structure and the same elements? Now, using a non-balancing binary search tree, let's rule out balancing for a second because we didn't do balancing. Okay, if I'm adding a node to a tree, actually, and if I do this for if I am adding a node to a binary search tree, doesn't matter if it's a balancing or self-balancing binary search tree, the first place it's going to end up in is as a leaf, right? It's going to end up as a leaf there, or maybe there, or maybe there, or there, or there, right? But it's going to end up somewhere as a leaf. And then the next step for a balancing search tree would be to balance it, but we didn't learn about that kind of stuff. So, okay, we're over here. So we add it as a leaf to the tree, and then we immediately delete it from the tree. Well, it's going to be deleting a leaf because the only place to add a new thing to the tree is a leaf. So deleting a leaf basically doesn't affect the structure of the tree at all, and it remains unchanged. Make sense to everybody? Suppose we have a heap and 2 values. So let's go ahead. So we have a heap and 2 values such that they are all distinct. Let H12 be the heap if you insert V1 and then V2 into H, and then 21 if you insert V2 and V1. Give an example of H, V1, V2 such that they're that inserting them in different orders means that they are not equal. So that's fairly straightforward in the sense that basically what it's asking is that we've got some pre-made heap already, which I'll say is 3 and 5. Okay. Some 3 and 5, and now we're going to insert some items into it. Let's go ahead and do 1 and 2 and 2 and 1. Okay. So I'm going to insert 1 into a min heap, which means that this becomes 1 and then this becomes 3. And then I'm going to do 2 over here, which means that which means that the 5 goes down here and the 2 goes here. So it becomes 1, 2, 3, 5. So 1, 2, 3, 5. Okay, so that was doing 1, then 2. Now let's do 2, then 1. So we had 3 and 5 as our first initial setup. If we do 2, let's see. Yep, this would end up being identical. So we need to figure out a different scenario. But getting them on separate sides of the tree seems to be it. Oh, 1, 5. And now 2 and 3 and 3 and 2. So 2 and 3, this would swap up and become 3 and 5. And then if I also now do 3 and 5, sorry, what was it? No, it was 1 and 5. And now do, so I did 2 and 3. Now I do 3 and 2. This is going to swap here. So 5 and 2. So our answers are 1, 3, 2, 5 and 1, 2, 5, 2, 3, 5. So those are 2 different things. So by adding at 2 different points, we ended up with 2 different answers. All right. So this one I also like, problem number 9. Suppose you have a graph like the one below. The dot signifies some part of the graph that you don't know exactly, not a straight line, not a straight link. So in other words, don't have an edge going straight from the start to the goal. You know, however, that there are many parts from the start to the goal. You also know that they tend to be rather long. Suppose that you want to implement a program that searches for a path and returns the first one it can find. You have no need for finding the optimal path, just any path will do. Would you want to use breadth first search or depth first search for your program? Justify your answer in at most 2 sentences. So any suggestions from anyone? You okay, Laser? So yes, depth. So the idea here is that breadth first search will find the optimal path, but it's not going to find it quickest because you're going to be basically you're going to find, if your thing is 10 deep, then you have to go through 10 layers of paths. Whereas depth first search is going to go basically make a beeline to try to find it, and it's going to go as deep as possible. If it hits a dead end, it will back up and try to find another one. All right. So yes, a depth first search is probably the best algorithm in this case. All right. Although I would be remiss to leave out an alternative idea that is used sometimes when you're doing social media social media graphs, which is that if you have a start point and an end point and you want to figure out what their shortest distance is, then one way to do that is to do breadth first search going from both sides and see where they meet up in the middle. So like I'll search my one node, I'll search distance 1 to over here. This one will search distance 1. And then this one will search distance 2, and look, it found a connection. So that's one way to do those kind of things. All right. So now what we're going to do is we are going to go into, I want you to open up Canvas and go to the, let's see, go to the final review quiz, which I imported. And then I found by giving it out this morning that it's got some errors on the stack and queue question, or not some errors, but some of the answers aren't correct. So just do the best you can on it. And what we're going to do is that we're going to go over it. Once everybody has done it, I'm going to turn the number of points down to 0. But I wanted to I wanted to see, the overall, just how everybody how comfortable everybody's feeling with the final exam. Because these are just some broad topics that will do everything that, words are apparently hard, and I'm starting to feel under the weather, as I mentioned. So, all right. So go ahead and open up this. This is under quizzes. Suppose I can even maybe drop it in chat. Let's see if that works. Let's see if that works. Student view. Yeah. So yeah, go ahead and take a look at the quiz. And then once you do it, I'm going to go ahead and go over it afterwards. So take about 10 to 15 minutes on this. Okay. I'll be checking in and then asking if people need more time. I'm going to go and get some water. You can't see the image on the browser for question 1 and question 5. So give me 1 second. Give me 1 second. Question 1. Yeah, give me a second. Stop sharing for a second. Okay. Why can't you see it? Is anybody else having issues seeing it? Okay. I just have to open it up in 2 different programs, I guess, to get them all so that everybody can see it. Okay. Give me 1 second. I'm going to share my screen again. Okay, question 1 on the left, question 5 on the right. Did not want to draw over that. All right, I'll be back. I'll be back very shortly. I just need to get some water. The quiz isn't under any modules. Check the quizzes tab on Canvas. I also posted it in chat. I'll post it again. So okay, so with that, I think we are done with our review. Do we have any questions before I dismiss the class?
Not about the exam, but about demoing.
Mm-hmm.
Just like, what do
Yes,
we?
I will be. So for demoing, so first off, I will send out the details for the exam before I forget that. Exam again, 3:30 on Friday, room 115, 116 in Circ. I will send out that room detail in an email as well as a reminder for the time. The demos. Once I dismiss class, I will be happy to take some demos. Okay. And then if you cannot demo at this point, you can email me or the TA to set up demoing at a later date. I will probably not be available for demoing until the weekend, but I'll be happy to do so this weekend. Okay. I cannot go over each exam question type like I did for exam 2 because that would give an unfair advantage to our students. But I can tell you that that basically if you go through that list of questions about what I care about, okay, again, with coding, you're not expected to be able to implement the data structures, but to use them. Okay. All right. So with that, class is dismissed. I'll be happy to take any demos that you have. And good luck. You did a great job this semester.